By the way, there's an interesting theorem in mathematics that says as long as these functions are continuous, as long as the partial derivative functions are continuous, that these cross partial derivatives will be equal to each other. This is called Young's theorem. I won't go through the details, but Young's theorem states that under normal conditions, f sub kl and f sub lk will be equal to each other. If there are certain continuity conditions that are satisfied. Okay. Actually, we can verify that for this production function. Actually, let's look at these second derivatives and these cross partial derivatives for this particular function right here. Again, what is f sub k? Bernard, what is f sub k? The marginal product of capital in this case. Well, no, f sub k would be partial q partial k, just by definition. But what would, Bernard, partial q partial k, what is that equal to in this case? If you were to differentiate this, if you were just to differentiate that with respect to k, what would you get? Well, just use the power function rule. K has an exponent of 0.5. So what do you do with this exponent up here?
Bring it down.
Yeah, you bring it down. So it's 0.5 times to the minus 0.5 because you're subtracting 1 from that. And what do you do with the L to the 0.5? Yeah, you just keep it as it is because it's just like a coefficient on k to the 0.5, so you just keep it. So that's our expression for the marginal product of capital. We have an expression for the marginal product of labor, f sub L, which is just partial q partial L. And that'll be found in a similar way, except we're differentiating with respect to L. So it'll be 0.5 k to the 0.5, L to the minus 0.5. This is the marginal product of labor. Marginal product of labor is going to be a function of k and L, given by this formula right here. Suppose we want to know what happens to the marginal product of labor as you increase the amount of labor used. Then we would want to look at the sign of f sub LL. F sub LL, as I just mentioned earlier, by definition is this. It's partial f sub L, partial L. So it's telling us how the marginal product of labor changes as L changes. And mathematically, what is f sub LL? What is it equal to? Well, you're just differentiating f sub L, which is this, with respect to L. So David, f sub LL will be what? We want to differentiate this. 0.5 times k to the 0.5 times L to the minus 0.5 power. Okay, so if we use the power function rule, We're differentiating with respect to L. We're differentiating this with respect to L. So what would it be, David?
Okay, would stay constant.
Right.
You bring down to 0.5.
Or, actually, it's,
Negative 0.5.
yes.
And then it would be negative 1.5.
Okay, minus 0.5 times 0.5 would be actually minus 0.25.
Yeah. Well, I'm sorry, I was thinking about above the L being negative.
Oh, okay. So we bring the minus 0.5 down. We multiply it times the 0.5 that's already there, times k to the 0.5, times L to the what power?
Negative 1.5.
Yes, exactly right. Now, the important thing about this is this negative sign out here. So what does that mean about the sign of f sub LL? The sign of f sub LL is what? John? Negative. So what does that mean? This is equal to minus 0.25 times k to the 0.5 times L to the minus 1.5 is the same thing as putting this in the denominator, L to the 1.5. So L to the 1.5 is always positive. K to the 0.5 is always positive. But this minus sign out here guarantees that f sub LL is negative. Okay. So what does that mean? What's the economic significance of that? If f sub LL is always negative, what does that mean? Yeah, that's exactly, Ryan. It's a law of diminishing returns, or the law of diminishing marginal productivity of labor. It means as you use more labor, the marginal product of labor is going to fall. Diminishing marginal productivity of labor. So f sub LL being negative is just diminishing marginal productivity of labor. It guarantees that the marginal product of labor falls as L gets bigger. As L gets smaller, the marginal product of labor would get bigger and move in the opposite direction. Okay. What about f sub kk? What is f sub kk in this case? Now, by definition, f sub kk is just partial f sub k, partial k. And f sub k is given by this expression right here. So f sub kk equals what? Andrew? Yeah, negative 0.25. Now we're differentiating with respect to k. Yes, k is now raised to the minus 1.5 power. Originally it's minus 0.5. Subtract 1, get minus 1.5 times L to the 0.5. And clearly, this is going to be negative 2. So in words, the fact that f sub kk is negative, in words, what does that mean? What does that mean? Michael? If f sub kk is always negative, what does that mean? Mm-hmm. Exactly. It means diminishing marginal productivity of capital. Okay. The more capital you use, the lower the marginal product of capital becomes. Okay. Diminishing marginal productivity of capital. Okay. All right, let's do one more. Now, this one is the cross-partial derivative. And actually, let's do both of them and verify Young's rule for this case. What is f sub kl in this particular case? Well, f sub kl is just the derivative of f sub l with respect to k. Now, who can tell me what f sub kl is? How is it?
125.
Okay. We're doing f sub kl. Right. So we're differentiating with respect to k. So you bring this 0.5 down times a 0.5 that's already there. 0.25 times k to the what power? How? Negative 0.5, right. Times L to negative 0.5 power. And what is the sign of FKL? Positive. Because k to the minus 0.5 and L to the minus 0.5 is always positive. See, actually this is the same thing as 0.25 divided by k to the 0.5 times L to the 0.5. So this denominator is always positive. So the numerator is 0.25, that's positive. So, okay. So f sub kl is positive. Who can tell me what that means in words? It's very important you be able to understand and be able to explain what these things mean in words. So if you can't do that, then you don't really understand it. So who can tell me what it means for f sub kl to be positive? What does that mean? Ben? Okay. Well, let's go back to this. F sub kl is this. What is this numerator here? Partial f sub l. What does that just partial f sub l mean? What is f sub l? Marginal product of labor. So this partial is basically just the change in the marginal product of labor. What's in the denominator? Partial k, that's just the change in k. So what this is telling you is what happens to the marginal product of labor when there's a change in the value of k. Okay. What happens? See, this is the partial derivative of the marginal product of labor with respect to capital. So this is telling you what happens to this when this changes. If it's positive, that means as capital goes up, what happens to the marginal product of labor? It goes up. And that makes sense, doesn't it? If workers have more capital to work with, they're going to be more productive. Okay. If workers have more expensive machines to work with, they're going to be more productive. If I'm digging a ditch with a ditch digging machine, I'm going to be more productive than if I'm digging a ditch with a shovel. The more capital I have to work with, the more productive I'm going to be. So it will only make sense that this would be positive. Okay. So the more capital workers have to work with, the higher their marginal product is going to be. By the way, let's just verify Young's theorem. This is f sub kl. We got this expression right here, didn't we? Suppose we reverse the order of differentiation. We do this. We differentiate the marginal product of capital with respect to labor. What is that equal to? Well, here's the marginal product of capital right here. If we differentiate this with respect to labor, what do we get? Well, we bring this 0.5 down, multiply it times that, you get 0.25 times k. Now we're differentiating with respect to L here, so we leave the k as it is, k to the minus 0.5. L, well, the exponent here was 0.5. Subtract 1, get minus 0.5. Bingo. Same thing. Same thing as we had up here. So this simply verifies, for this particular case, that Young's theorem holds, that the order in which you do the differentiation doesn't make any difference. F sub KL is equal to F sub LK. Okay. But what this would mean in words is something different, though, doesn't it? What does this mean in words? Who can explain what this is now in words? Yes, Jay.
It's measuring the change in the marginal product of capital when we have a change in labor.
Exactly right. Exactly right. It's telling us what happens to the marginal product of capital when we change labor. And the fact that this is positive means if capital has more labor to work with, the marginal product of capital is going to be bigger. Makes sense. Okay. All right. The marginal product of capital is going to be higher the higher the value of L, because this is positive.